Problem 5. Summation x to the n over n plus 6. This has a centered x equals 0. Not geometric, so use the ratio test. Limit as n approaches infinity of the n plus 1 term over the nth term. So the absolute value of x to the n plus 1 over n plus 1 plus the 6 over x to the n over n plus 6. Flip the fractions upside down. We have the limit as n approaches infinity of n plus 6 times x to the n plus 1 over n plus 7 times x to the n. Now the limit as n approaches infinity of n plus 6 over n plus 7 will turn into a 1, and x to the n plus 1 over x to the nth will turn into the x. So all we're really seeing there is the absolute value of x. So now we know that the power series x to the n over n plus 6 converges for the absolute value of x is less than 1. And we also know that the ratio test fails for the absolute value of x equal to 1. And it diverges for the absolute value of x greater than 1. So our convergence will lie in between -1 and 1, and again we do not know about the endpoints. So the two endpoints, x is equal to -1, would create an alternating series, summation -1 to the nth over n plus 6. X equals 1 would create 1 over n plus 6, a positive series. And now we have to determine whether these two series converge or diverge. Taking a look at the positive series, summation 1 over n plus 6, you hopefully saw a limit comparison. And compare that to 1 over n, which is a p series. Power is 1, less than or equal to 1, so 1 over n diverges. Now we take the limit as n approaches infinity of the known series 1 over n over the unknown series 1 over n plus 6. We flip that upside down. We have the limit as n approaches infinity of n plus 6 over n, which is 1. Since 1 is positive and finite, or 0 is less than 1 is less than infinity, the series 1 over n plus 6 diverges, which also means then that the power series x to the n over n plus 6 diverges at its endpoint, x is equal to 1. So in our picture we're showing convergence in the middle, and we have 1 being not included in that interval because it creates divergence. And now I check the other endpoint, -1. So we get -1 to the nth over n plus 6, alternating series test. Condition 1 says take the limit as n approaches infinity of 1 over n plus 6, that's certainly 0. Condition 2 is 1 over n plus 6 greater than 0, without the alternator it is. Condition 3 is 1 over n plus 1 plus 6 is that smaller than 1 over n plus 6. Doing a little bit of algebra, we have 1 over n plus 7 is less than 1 over n plus 6. Then cross multiplying, we get n plus 6 is less than n plus 7. Subtracting n, we get 6 is less than 7, which everybody can agree that that's a true statement. So in conclusion, we see that the power series x to the n over n plus 6 has a center at x equals 0. It converges on the interval -1 to 1, where -1 is included and 1 is not included, and the radius is 1.